So the first thing we're going to do is review trig functions from geometry. So you have seen SOHCAHTOA before. SOHCAHTOA does have an abbreviation for your sine, cosine, and tangent functions. So sine is representative of looking at your triangle and identifying your opposite and your hypotenuse sides. For CA, the CAH, this is for cosine. And cosine is where you look at the adjacent side and the hypotenuse. And then the last part is TOA, which is your tangent. When you look at your triangle, you're looking at your opposite side and your adjacent side. These are always looking at some reference angle theta, which is going to be somewhere on your triangle. So you're always referencing some angle theta. So for the questions below, I'm just going to do the first two with you. It says to write the triangle ratios of your angle theta given two sides of your right triangle. So we're going to use this reference triangle for the three questions below. So for question number 1, this says we need to find the following values for sine all the way through cotangent for C equals 13 and B equals 5. So I'm going to redraw my triangle, the given one that's at the top. And this is my 90 degrees. This is side A. This is B. And we know B to be 5. And then your hypotenuse is C, which is 13. The reference angle that I'm looking at is theta. So that's in this top corner here, which is theta. So this angle is theta. Okay, well, using my trig functions, I need to identify the different sides. In order to do that, I need to identify what A is. How can I find out what A is? Pythagorean theorem. So over here to the side, I'm going to do by the Pythagorean theorem. We're going to actually find out what that A side is. So we're going to do A squared plus B squared equals C squared. A is unknown. B is 5. And C, whoops, let me not write C. C I actually do know, and that's 13. You really don't need your calculator for this. We're just going to simplify. A squared plus 25 is equal to 169. I'm going to subtract 25 on each side. Don't know why I rewrote a 6. So A squared is going to equal, let me see, 9 minus 5 is 4, 144. From here, I'm just going to square root both sides. The square root of 144 is technically positive and negative 12. Which 12 should I put in this spot? Positive. You don't want to have a negative side length because that won't make sense. So let's put this as a positive 12. All right, let's go ahead and answer the trig functions that are over here to the far right. So for sine, we're going to make this based on that trig identity part up here, what it's identifying. We're going to do opposite over the hypotenuse. Cosine is the adjacent over the hypotenuse, and tangent is opposite over adjacent. So looking at this triangle from theta, opposite is 5 over the hypotenuse, which is 13. Cosine of theta, that's adjacent. So from theta, adjacent is 12 over the hypotenuse, which is 13. And then tangent is where you have opposite, which is 5, over the adjacent side, which is 12 right here. What are these on this far left or far right-hand side? What are these three? Y'all made it out of geometry somehow. No, you have. What do the CSC, SEC, and COT stand for? COT should be pretty easy.
You said it was cotangent.
Cotangent. Okay, so we have cotangent here. SEC, what does that mean? Secant. And then what about CSC? It's very similar to secant. Cosecant. Those are the three different inverse functions. So in case you don't remember from geometry, welcome back. CSC is cosecant. This is the inverse of sine. So here are your inverse functions. The inverse of sine is cosecant, so CSC of theta is going to be 1 over sine of theta. Secant, SEC, is going to be 1 over cosine of theta. And cotangent is going to be 1 over tangent of theta. Those are all inverses. So cosecant is the inverse of sine and vice versa. Sine is the inverse of cosecant. So when I'm writing out the ratio, because I need to identify the ratios on this graph or on this triangle that I have, cosecant is just the inverse of sine. So I could make this 1 over 5 over 13, which means I'm going to have to keep, change, and flip. All you're doing for these ratios is you're doing the reciprocal. This is going to be hypotenuse over opposite, hypotenuse over the adjacent, and adjacent over your opposite. So that's how you identify which side lengths you have. You can do plugging each of these ratios into these fractions, but you really don't have to. That's just extra work. So from this table, from this triangle, the hypotenuse is still 13. The opposite side is 5. Notice that I just flipped this fraction. For secant, hypotenuse is still 13. The adjacent side from theta is 12. And then the last one is tangent. So adjacent is going to be 12. Opposite is 5. I literally just flipped all of these fractions to give me cosecant, secant, and cotangent. So right now, I want you guys to do number 2. Number 2 says, do not simplify or rationalize your denominator. So if you have a radical, do not write it as a decimal. Just leave it as a fraction form. That's all. So right now, I'm going to give you guys about 2 or 3 minutes. Do number 2. So right now, redraw your triangle. Do number 2. Remember, when you're redrawing your triangle, you're using this exact same triangle for numbers 1, 2, and 3 if you choose to do 3. So this triangle is the same theta that you're going to be using, this angle up here. All right, so for question number 2, remember, sine, cosine, tangent, you're looking at opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. If you redraw that triangle like I asked you to do, this is theta. A is 2, B is 3. What was the hypotenuse here? Square root of what?
13.
13. So when you're making those ratios, you don't need to rationalize it. So we're going to refresh your memory as to what rationalize means, but not right now. So from theta, opposite is going to be 3 over the square root of 13. Adjacent is going to be 2 over the hypotenuse, which is square root of 13. And then opposite over adjacent should have been 3 over 2. For cosecant all the way down to cotangent, you're just doing the reciprocal of these. So I'm just going to flip those around. Square root of 13 over 3. Square root of 13 over 2. And then 2 over 3. Those are all of the ratios that you should have gotten. Questions, concerns, fears from this page? All right, good. Let's go ahead and move over to the next page. So question 3 at the bottom, it does tell you to rationalize. If you don't remember to rationalize, I'm going to actually show you how to rationalize on the first question on the next page. So let's go ahead and look at right triangle trigonometry practice with the calculator. Let's go through a few of these questions. I'm not going to do all of these today. Definitely don't lose this page because, for instance, questions like number 2, you don't know how to do that yet. So I will show you guys how to do it when we actually get to this concept. So for the first part of this page, it says for the exact value of x and then approximate your answer in 2 decimal places. So round your final answer. Okay, I'm going to look at question number 1 first. Question number 1 says this angle here is 30 degrees. We have a 90-degree angle here. What's the angle up here? If this is 30, this is 90. What's this angle here? 60 degrees. So with that angle up here, we have a 30, 60, 90 special right triangle. If you remember how to do this from geometry, cool, you could do it. But I'm going to give you guys another way just in case you don't really like having to memorize. This will be only one thing you have to memorize. So for a 30, 60, 90 triangle, there's a pattern that goes along with it. Right across from each of the angles is a specific number. The way you have that number is 1, square root 3, and 2. We're doing something to that side length depending on what it is. So with this pattern of 1, square root 3, and 2, I'm going to set up a ratio. What that ratio means is what's directly across the 30, 60, and 90 degree angles. So right across from the 30 degree angle, you have x. So right across from your 30 degree angle, you have x. That's the unknown. That's what I need to solve. I need to find the exact value of x. Right across from 60, I have 10. That's at 10 feet. And right across from 90, I just have the hypotenuse, which I don't know what that is, so I'm just going to put a y. We don't need to find y, we only need to solve for x. In order to use this method, which is pretty simple and it will always help you with finding your answer, you need to have at least one full fraction that's nothing but numbers. So see how this fraction here has a number in the numerator, number in the denominator? This is important. We are solving for x. I'm going to use these two fractions and set them up as a proportion. So when I say set them up as a proportion, you're going to do 1 over x equals square root of 3 over 10. This is just one way of solving, guys. There are plenty of ways to solve this question. I'm just trying to give you guys another way in case you didn't really like or learn this from geometry. Once you have this fraction, guys, you're a fraction equal to a fraction, we're going to solve. X times the square root of 3 is going to equal 1 times 10, which is 10. How do I get x by itself? Divide by the square root of 3. So x is going to equal 10 over the square root of 3. Before I write this as a decimal, let me rationalize it. Carlos, what does it mean to rationalize? What do you have to do with that radical? And the top as well. That's exactly it. Rationalize means you need to get rid of that denominator that has that radical. So when you do that, Carlos, what are you going to be left with in the numerator? No, not just 3. In the numerator. 10 square root of 3. And what about the denominator? Just 3. Because square root of 3 times square root of 3 is the square root of 9. And what's the square root of 9? 3. This would be your answer if I asked you to rationalize it. So I would write that in feet, and that would be your answer. So in case you forgot how to rationalize, this is it. But since it does ask me to round it to 2 decimal places, I'll just do that as well. So up right above it, I'm going to put x equals. Let me actually divide 10 by the square root of 3. So get your calculator out, please. And your calculator, obviously, it's the middle of the day, so we've probably had a few things in here. I'm just going to go to the home screen, and this is what I want you guys to do every time that you get a graphing calculator. So go to the main screen, look up, and you're going to reset it. If you push the back of the button on, or the button on the back side of the page, and you break it, you buy it, I will charge you for this. Instead of breaking it, go to My Documents, hit Enter, push the menu button, and you're going to scroll up or down to option C, which is Delete All. Hit Enter, and it asks, do you wish to proceed? Push OK. When you see this message, guys, it's been successfully reset. Do not push the button on the back because if you break it, I will charge you. All right, questions on how to reset? Okay, beautiful. Let's go ahead and look at how to plug this in. So go to a new document. Look up one more time. If you go to Scratchpad, you're going to get confused later on today when I start doing more things. Do not use Scratchpad. Ignore this side. Go to a new document. In your new document, we're going to add a calculator, and I'm going to type in 10 divided by the square root of 3. So I'm coming back up to here, if we were just solving with the decimal. We're going to type in a fraction. The way I did a fraction was just control division sign. 10 divided by the square root. So I just hit gold and then x squared of 3. So 10 divided by the square root of 3, that is about 5.7735. If I round this to 2 decimal places, I'm going to make this x as approximately 5.77 feet. These are my answers. So I wanted to show you guys how to rationalize it just in case you forgot, but from here on out, I'm going to be writing them in decimal form. So I wanted to show you how to get both answers. All right, let's look at our next problem that we're going to do. I'm not going to do 2 and 3 yet. I haven't taught you guys how to do it. So let's look at question number 4. Have I lost anybody with what I did before I move on? You okay? Okay. All right, for question number 4. I have a 45-degree angle. What's this angle up here going to be? 45. This is another special right triangle. This is a 45, 45, 90 triangle. Just like with the pattern you had for 30, 60, 90, there's another pattern for this one as well. So this is 45, 45, 90-degree triangle. The pattern is 1, 1, square root 2. When both of your base angles in a triangle, or at least both of these angles here, are the same, what does that mean about the side lengths? What does that mean about this side length here and this side length? Say it again. They're the same. So what type of triangle is this? It begins with an I. Isosceles triangle. So that means it doesn't really matter which x I solve for. They're both going to be the same length. So we're going to go directly across from our 45-degree angles and identify what side is across from it. So directly across, it doesn't matter which 45-degree angle you use. Directly across from this 45-degree angle is x. Directly across from this 45-degree angle is also x. And directly across from your 90-degree angle is 25 feet. Like I said on the last question, you want at least one of the fractions to have numbers in the numerator and denominator. Numerator and denominator, they are both numbers. It doesn't matter which x you solve for, they're both the same. So I'm just going to use the last two. It's going to be the same 1 over x because it's a 45-degree angle. And we're going to set up a proportion. This is just one way to solve these problems. What do I do from here to solve for x? Cross multiply. So x times the square root of 2 is going to equal 25. And in order to get x by itself, I'm going to divide both sides by the square root of 2. So like I said, you're going to use your calculator. You don't need to rationalize because the directions say to round it to 2 decimal places. We're going to do the fraction button again. And I'm going to put in 25 divided by the square root of 2. So we'll have 17.6777. So I'm just going to round that to 2 decimal places. My units are in feet. Welcome back to the days of units. And we're going to round that answer. On your tests and quizzes, guys, if I don't give you a calculator and I ask you to write like the exact form, rationalize the denominator. But since I gave you guys a calculator, you can round it. All right, we're going to look at a couple more questions. Let's flip it over and look at question number 8. If I'm moving too fast, please let me know. All right, for question number 8, this is the triangle we're looking at. Some students have a difficult time with identifying the different parts of this triangle, so if you need to redraw this, you can. Especially since you haven't seen geometry in a couple of years, I'd probably redraw this just to make sure. The bottom side here is x. The hypotenuse is 49 feet. And this angle at the top is 26 degrees. It's having the same directions from the first page, which says that you need to solve for x and round your answer to 2 decimal places. Okay, so I need to figure out, this isn't a special right triangle. 26 does not have a nice, pretty trick that goes with it. So I'm going to have to use SOHCAHTOA. Heidi, which trig function should I use to solve for x in this triangle? You have 26 degrees, so which trig function will be useful? We don't need to do inverses of sine. Let's just use the actual sine, because sine is opposite over hypotenuse, right? Up here, sine is opposite over hypotenuse. We have the opposite side from 26. We have the hypotenuse, so we don't need to use any inverses. We're just going to write this as sine of 26 degrees is going to equal x over 49. That's all. No need for inverses just yet. If I was going to solve for x for this, Hussein, how would I get how would I get rid of the 49? You can multiply both sides by 49. So I'll get 49 times the sine of 26 degrees is going to equal x. and your calculator. If you just typed this in and you wrote your answer, you're wrong. What do you have to do? How do you put it in degree? All right. Main thing, guys, you have to put this in degree mode. Look up. Let me show you how to put it in degree. Hit doc, D-O-C. You're going to scroll down to option 7, which is settings and status. Hit enter. And you're going to hit option 2, which is document settings. Check the person next to you. Make sure you guys are on the same page. So double check. Look, because if you guys have a question, I can't help you. Look with the person next to you. Make sure y'all are at the same spot. We are going to change from radians into degree. So down to radian, you can hit the arrow over to make the drop-down menu come out. And you're going to hit the second option, which is degree, and hit enter. I get lazy. I don't like to have to scroll down, so I just hit tab all the way down until you get to OK. When OK is highlighted, hit enter. If you don't see that OK button, guys, you're in Scratchpad, like I told you not to be in. So make sure you have that OK button and that you have this in. How can you tell that it's in degree mode? Look at your calculator. How can you tell it's in degree mode? It says degree right up here. So when you're doing this, guys, check the top corner of your calculator. If it doesn't say degree, you've messed up. So double check, because I can't walk around to see all of you guys at once. Make sure the person next to you has the same thing. Now that it's written correctly, we're going to take this and plug it in. So we're going to have 49 times the sine. So hit trig. Sine is the first option. We're going to hit enter and type in the 26 degrees. It's already in degree mode, so don't worry about putting that degree symbol. Hit enter, and we're going to write this out. So this is 21.4802. I'm just going to round it to the nearest hundredths place, which is 2 decimal places. And these units are in feet. That's my answer. Yes, ma'am.
The other form that you like, would you make us convert that?
What do you mean?
Like you said on the quiz, you ask us a question.
So if I don't give you a calculator, let me go back. If I don't give you a calculator, you can give me this as your answer. Because obviously you can't solve that for a rounded decimal by hand. I don't want you to. So if I don't give you a calculator, give me this answer. As you have a calculator, you can give me the decimal. That's all I was saying. All right. Are we good with number 8? Let's look at one last question. Flip it over to the very back page. We're going to look at number 17. All of the rest of these questions, don't say, oh, Ms. Tapia, you're skipping all of them. Yeah, I know. But we're going to come back to this exact same packet in a couple of days. All right, for 17, let's go ahead and look at 17. First thing that I want you to notice for 17, this 32 degrees is for angle A. So make sure you note that that 32 degrees is for angle A. Think back to geometry. I know it was a rough time for some of you, but when it says to solve the triangle, what does that mean? What does it mean to solve the triangle? You have 17, you have this. What do I mean by solve? I don't see a variable. What do you need to find? All of the sides, and what about the angles? All the angles. You need to find everything. So this means you need to find all of the sides and your angles. You have to find everything, guys. So in case you forgot from geometry, solve the triangle means to find everything. So for question 17, I need to find angle B, which is inside. I need to find this guy. I need to find this side length here for BC, so I'm going to label that as X. And I need to find the hypotenuse, which is labeled, I'm going to label it as Y. I'm just giving it unknown so you can see what we need to find. What's the easiest thing to find on here first? How are you going to find angle B? Okay, so you're telling me to add some things and then subtract, but what tells you to do that from geometry? What theorem? No, there's a name of it. What's the angle theorem that tells you to add up all of your sides inside your triangle and equal it to 180? Begins with a T.
The triangle theorem.
Not just triangle theorem. Triangle sum theorem. So by the triangle sum theorem, that means you could take angle A plus angle B plus angle C and set that equal to 180. That's why you need to do that. So I'm going to add up all of my angles. Angle A is 32 degrees. Angle B is just B. C is 90 degrees, and we're setting that equal to 180. All right, well, let me combine my two sides and then subtract. So we're going to make this 32 plus 90, if I could actually write correctly. So that's going to be 122 plus B is going to equal 180, and then I'll subtract 122 on each side. So angle B is going to equal 180 minus 122, which is 58 degrees. As Jorge just said, when you're solving your triangle, you need to find everything. We found all of the angles, perfect. We now need to find the two missing sides. So step 2, we're going to find x. Okay, so to find x, just take a second and look at it. I'm probably going to need to use a trig function. So SOHCAHTOA. Valerie S., which trig function do you want to use to solve and find x? And first of all, which angle do you want to reference? Do you want to reference angle A or angle B? Angle A. I like to use the stuff that's already given, so yeah, I like using angle A too. So using angle A as your reference, should you use sine, cosine, or tangent to find x? Do you have a hypotenuse? Sine, you said sine requires a hypotenuse. We don't want to use ones that have a hypotenuse because we don't know what that value is. We have the adjacent side. So which one has the adjacent and the opposite side? Tangent. Let's use tangent. So to find x, we're going to use tangent of 32 degrees, and that's going to equal the opposite side over the adjacent side, which is 30. This is what you're solving. So we're going to multiply 30 on each side. So we're going to have 30 times the tangent of 32 degrees is going to equal x. All right, I'm going to take my calculator, double check that the top part of this says degree. If you accidentally exit out of this, take a second and look up. You go back into a new document, it's not going to save it for you. So you're going to go back into calculator, make sure that this is in degree mode, and then plug this in. So let me quickly put this back into degree mode since I exited out. Y'all can plug this in. So we're going to put this in degree mode. I'm going to tab all the way down. And I'm going to type in 30 times the tangent of 32 degrees. So x is going to be equal to 18.7461, which is about 18.75 inches. Don't forget your units, guys. There are plenty of ways to solve this. Just pick one method and then solve. So the last step, step 3, we need to solve for y. So I'm going to be kind of lazy. I'm going to keep using angle A as my reference. You can use angle B since we found it, but I'm just going to use angle A, and I'm going to find my y value. So we're going to do, let me see, I have a hypotenuse, I have the adjacent side. Let's use cosine. So we're going to do cosine of 32 degrees is going to equal adjacent over the hypotenuse. This is what I need to solve. What's another way you could use instead of using one of the trig functions? If I wanted to find y, you can use Pythagorean theorem. If you use Pythagorean theorem, though, guys, don't use the simplified decimal. Use the long decimal number to get a correct answer. Okay, so for this one, I'm going to actually cross multiply. So we're going to have 30 is equal to y times cosine of 32 degrees. Jenny, how do I get y by itself? In this equation, how do I get y by itself? How do I get rid of the cosine? Come on, Jenny, what's the opposite of multiplying? Say it again. Dividing, thank you. We're going to divide both sides by the cosine of 32 degrees. So y is going to equal, okay, let me plug that in. You put my fraction, 30 divided by cosine of 32 degrees. Make sure it's in degree mode. And I'm going to get about 35.3754. So y will be approximately 35.38, and this is in inches. This would be my answer. All right, take a second and look at this. Are there any questions about what I just did?
So, about data, right? So we're always going to use 32 degrees. Like, how do you know which one is theta?
whichever angle you want to use. So I wanted to use angle A. It was already given, so I just used angle A as my theta. You could have used angle B. Angle B is 58 degrees. You could have used that, but you wouldn't have probably used the same tangent and cosine trig functions.
What if it's like